Hey everyone, and welcome. If you're working in modern IT right now, you already know the absolute headache of managing massive hybrid multi-cloud environments. I mean, one day your organization is entirely on AWS, the next day some new project spins up on Azure, and suddenly managing all of that manually becomes just a total nightmare. To solve this, two absolute giants of automation have emerged: Ansible and Terraform. But, with both of these tools claiming to automate your workflows, this massive showdown has developed in the DevOps community. Which one should you actually use? And more importantly, for what?
So it brings up a question I hear all the time from engineers. Why on earth do you need two tools to automate one single cloud? If they're both famous for automation, why can't I just learn one, use it for literally everything, and save myself the trouble? It really is the core mystery of modern DevOps toolchains. Well, today we're going to unravel that mystery completely and look exactly at how these tools operate.
Okay, let's dive into this heavyweight bout. Here's our game plan. 1. The Great Automation Confusion. 2. Terraform, building the foundation. 3. Ansible, configuring the inside. 4. The crossover problem. And finally, 5. The ultimate DevOps workflow.
Starting with Section 1, the Great Automation Confusion and the absolute headache of manual infrastructure.
Imagine you're a DevOps engineer, right? And you need to manage the configuration for a fleet of servers. Now, in the old days, people would just write a shell script to do this. And honestly, that's fine for maybe 100 servers. I mean, writing a shell script for 100 servers means a really long night and way too much coffee. But 10,000 servers? That's not a long night. That's literally a reason to update your resume. It just becomes technically impossible to manually log into each machine, run a shell script, and verify that all your packages were installed securely and compliant. Plus, what if half the servers are Linux and the other half are Windows? Suddenly you're writing completely different scripts, Bash for Linux, PowerShell for Windows, and trying to loop them over 10,000 individual machines. It is a total recipe for disaster. So automation wasn't just a luxury anymore, it became a strict necessity just to survive.
Moving on to Section 2, Terraform, building the foundation, utilizing infrastructure as code.
Think of this whole thing like real estate. Before you can even think about decorating a house, you've got to pour the concrete and build the physical foundation, right? And that is exactly what Terraform does through something called infrastructure as code. It's this incredibly smart, universal approach to automate infrastructure provisioning. To really get why Terraform is so popular, you kind of have to look at the alternatives out there. AWS has CloudFormation, Azure has Bicep or Azure Resource Manager. Google has its own SDK. So if you switch companies, or if your company moves to a hybrid cloud model, you'd have to learn a dozen different proprietary tools and APIs. Nobody wants to do that. Terraform completely abstracts all that heavy lifting. It uses an API as code architecture. You just write out your infrastructure requirements, and Terraform translates that directly into the exact API requests for whichever cloud provider you happen to be targeting.
So Terraform is incredibly powerful for a few specific reasons. First off, it uses HashiCorp Configuration Language, or HCL for short. And the great thing is, it reads almost like plain English. You literally just state that you want a virtual machine, and Terraform's API's code architecture reaches out and makes all those complex HTTP requests to AWS or Azure to provision it for you. It's got universal multi-cloud support, so it acts as a single pane of glass for practically any provider. And finally, and this is absolutely crucial, it uses state files. This means Terraform actually tracks your infrastructure internally. You don't have to manually log into your AWS console just to see what resources are currently running. Your Terraform state file keeps a perfect running record of the foundation you've built.
All right, Section 3, Ansible, configuring the inside, better known as configuration management.
Okay, so if Terraform poured the concrete foundation and built the walls of our house, Ansible is the crew coming in to install the plumbing, wire the electricity, and paint the walls. We call this configuration management. You see, now that Terraform has given you those raw servers, they're essentially just empty boxes. They aren't actually doing anything useful yet. Configuration management is the automated method for taking those existing servers, installing the necessary software, managing your security updates, and maintaining a desired state. Basically, Ansible takes the servers Terraform just built and breathes life into them so they can actually function as web servers, database nodes, or literally whatever your application needs.
Now, while Ansible is technically written in Python, you don't actually need to know Python to use it. You write these really simple YAML scripts called playbooks. But the real magic here, that's in its architecture. Older configuration tools like Puppet, for example, used a pull model, which actually required a master server and these slave agents installed on every single target machine. Ansible, on the other hand, uses an agentless architecture. It doesn't require you to pre-install anything on the target servers. Instead, it relies on a push model. As long as you have a public IP address and SSH enabled, Ansible is just going to push the configuration right directly to the server. And when you add in dynamic inventory, which basically means Ansible automatically recognizes when Terraform spins up 100 new auto-scaled servers without you ever manually updating a list, you end up with an incredibly efficient way to configure massive environments.
Which brings us to Section 4, the crossover problem. Basically, what happens when these tools step on each other's toes? Because both of these tools are just so incredibly powerful, people naturally try to make them cross paths. It happens all the time. You'll sometimes see DevOps engineers trying to use Terraform to manage granular software configurations inside a server. Or, on the flip side, they'll try to use Ansible to provision complex cloud infrastructure like virtual private clouds and load balancers. But look, just because you can buy movie tickets on multiple different apps doesn't mean you shouldn't just use the one best designed for the job, right? When you force Terraform to manage software, those state files we talked about become a cluttered nightmare. And when you force Ansible to provision complex infrastructure, you completely miss out on Terraform's robust state management. It just leads to messy, incredibly difficult to manage environments. Actually, industry best practices hit the nail right on the head here. To quote directly, Terraform is built for infrastructure automation. Ansible is built for configuration management. It really is that simple. This firmly establishes the rule of thumb and entirely resolves the whole versus debate. They aren't enemies competing for the exact same job. They have highly specialized, distinct purposes.
Let's move to Section 5, the ultimate DevOps workflow where these tools work in perfect harmony. Let's actually look at how this plays out in a real-world scenario. Imagine you need to deploy a Kubernetes cluster. Step 1. Terraform reaches out to AWS using its API as code and provisions 3 raw EC2 instances. It handles all that heavy lifting of the cloud infrastructure. Then, Step 2. Ansible takes over. Setting up Kubernetes takes maybe 50 to 60 distinct configuration tasks, dealing with certificates, networking, software packages. Doing all that in Terraform would make the file completely unreadable. Instead, Ansible seamlessly logs into the newly created infrastructure via SSH, configures one instance as the master node, and then easily configures the remaining 2 instances as worker nodes. They just collaborate flawlessly. Terraform builds the house, Ansible makes it a home.
So, to wrap this all up, take a hard look at your own organizational workflows. Truly understanding the distinction between infrastructure as code and configuration management is exactly what separates a messy pipeline from a scalable, automated masterpiece. Which brings me to a final question for you to chew on. In a world of hybrid clouds, are you using the right tools to build an unbreakable foundation, or are you just trying to decorate a fragile house? Think about how you're using these tools in your own environments today. Thank you so much for joining me on this explainer,